Welcome everyone to this course. This course is all about how to create YOLO V9 deep learning project in the RoboFlow website. So this course consists of different kinds of classes. In the first class, we are going to discuss about how to create the project workspace in the RoboFlow website. In the second class, we are going to create dataset for our project. In the third class, we are going to discuss about how to annotate these dataset for our project. In the fifth class, we are going to discuss about how to train this dataset with the YOLO V9 model. In the sixth class, we are going to discuss about how to validate these dataset with the YOLO V9 model. In the final class, we are going to discuss about how to run this project in the Python IDE. So this course is very useful for the students who are trying to create the YOLO V9 deep learning project for the first time. And also you have to familiarize yourself with the RoboFlow website for creating n number of deep learning and also machine learning projects. Hope I can see you in the course taught by me. So let's get started. Welcome everyone to the first class. In today's class, we are going to see about how to create our project workspace in the RoboFlow website. Before creating your project workspace, you have to create your account in the RoboFlow website. For that, you have to use your Google account to create an account in the RoboFlow website. After creating your account, you have to create your project workspace. For that, you have to type your project name in the workspace. So our project is about fire detection using YOLO V9. So that's our project in our course. So you have to type your project name and then you have to choose any one of the plans in the RoboFlow. For that, you have to select a free plan in the RoboFlow website. After that, you have to select skip. So that's it. We have created our project workspace in the RoboFlow website. After that, you can see there are different kinds of options available in the RoboFlow website. The first one is the object detection. So you can detect the object in your video or image. And the second one is the classification. It classifies the image. So in the example, you can see the good and defective. And the third is the instance segmentation. So you can use instance segmentation for detecting the multiple objects with their actual shape. For our project, we are going to choose the instance segmentation. So you can also select any one of them, but we are going to select the instance segmentation. After that, you have to type your object name. We are going to detect the fire. And then you have to select any one of the license. And then you have to type your annotation group. So annotation group is nothing but our class. So you can also see there are many other options available in the RoboFlow website. So we are going to select only the instance segmentation option only. So you have to type your annotation. Our annotation class is fire. So we are going to detect the fire in the real-time objects. So that's it. In today's class, we have completed how to create our account in the RoboFlow website, and also we have discussed about how to create our project workspace in the RoboFlow website. In the upcoming class, we are going to discuss about how to create dataset for our project fire detection using YOLO V9. So that's the topic we are going to discuss. So let's see you in the next class. Welcome everyone to the second class. In today's class, we are going to create our dataset for our project fire detection using YOLO V9. For that, you can see different kinds of options available for creating your dataset. The first one is the select files, and the second one is the select folder, and then third one is the YouTube video. You can type your YouTube URL link in the RoboFlow website. And the next option is universe dataset. You can select any one of the dataset in the RoboFlow website. For that, we are going to see an example. You have to open that link. So in that, RoboFlow itself consists of different kinds of dataset for your project. It consists of 5 million dataset and 1 million fine-tuned modules and different kinds of images for your project. So you can search your project dataset in the RoboFlow website. For our project, we are going to search the fire detection dataset. For that, you have to type fire and then you have to search for the dataset in the RoboFlow website. So you can see there are a lot of dataset which contains the fire reduction images. So you can use any one of them for your project. So these datasets are very free. You can select any one of them. So you can also see their model trained values. You have to select this option. So in that you have to download their dataset. For that you have to select this and then you have to select the format. For that we are going to choose YOLO v9 and then you have to select download zip to computer. At last you have to select continue for downloading their dataset. After the dataset is downloaded, you have to open that. In that you can see there are many files and folders. The first one is the test. In the test you can see two folders. First one is the images. So images consist of all dataset for the fire images. So you can see many number of dataset for your project. Also you can see their labels. So label consists of coordinates of the fire images. Also you can see other folders. So you can use this dataset for your project. So this is the first method to download your dataset. After that we are going to discuss about the second method, that is Kaggle dataset. So we are going to use the Kaggle dataset for our project. For that you have to type your dataset name, fire reduction dataset Kaggle. So Kaggle is a very useful for machine learning and also deep learning dataset. It consists of millions of dataset for our project. So you have to open that Kaggle website. So in that you can see all the images for our fire reduction dataset. So you can see there are many files available for your fire reduction dataset. In the folders you can also see their images of fire. So you can use this dataset for your project. So you can see many number of fire images. Before downloading your dataset, you have to sign in the Kaggle website. After the sign in is completed, you have to download your dataset. So this is the second step for downloading the dataset in the Kaggle website. After that, after downloading all the dataset for your project, you have to upload your dataset in the RoboFlow website. For that you have to choose select file option. So you have to drag and drop your images or upload your images. So you have to select your folder. So you have to wait for the processing. So after uploading all the images for your project, you have to select save and continue. So you have to wait for the RoboFlow website to upload your dataset. After the completion of your dataset uploaded in the RoboFlow website, you have to select assign images option. So that's it. We have completed how to create dataset for our project fire reduction using YOLO v9 in the RoboFlow website. So there are two methods for downloading the dataset. The first one is the RoboFlow website and the second one is the Kaggle website. So we can choose any one of them for your dataset. So in the upcoming class we are going to discuss about how to annotate these dataset for our project. So let's see you in the next class. Welcome everyone to the third class. In today's class we are going to discuss about how to annotate these dataset for our project fire reduction using YOLO v9. You have to select start annotating option. So this is the GUI of the annotation in the RoboFlow website. In the left hand side you can see the options like attributes, comments, history and the raw data. So in the annotation you can see the two different options. The first one is the classes and the second one is the layers. You have to choose the classes option. In the right hand side you can see different kinds of tools for annotating your dataset. We are going to discuss one by one. The first one is the drag tool. So drag tool is nothing but you can drag your images based on your own position. So you can drag any position you want. So that's the use of the drag tool. And the second one is the bounding box tool. It creates the bounding box for annotating our data set. So you have to select the bounding box tool and create a bounding box that is rectangle or square. And then you have to type the class name that is fire. So you have to type the class name and then select save enter. So this is the class for our project fire detection. So this shows the fire is detected in the image. So this is the first step in the annotation. After that, we are going to discuss about the second tool, that is polygon tool. It creates the polygon line to detect the fire images in our data set. So it creates the polygon line. So you have to select the polygon line tool and creates the line for your data set. So this shows that the fire is detected in our data set. After that, we are going to discuss about the smart polygon tool. So it is an AI tool which automatically detects our classes in the dataset images. So you have to select your class that is fire in the dataset image and then type your dataset name, that is class name. So you have to select save enter. So it automatically detects the classes. After that, we are going to discuss about the label assist. So label assist is nothing but it helps to train our model from the starting point. So you can choose the label assist if you want. And the next tool is repeat previous. It automatically repeat the previous actions you have done in the dataset. And the next tools are comment. So you can use the comment option and then redo, undo. And the last option is mark null. So it removes what are all the annotation you have done in that dataset. So you have to select mark null. It automatically removes all the annotation you have done. So you have to again do the annotation and save your class name. Mostly we are going to use the bounding box tool to create our annotation in the dataset. So you can also use other tools for creating the annotation and save your class name. So you can also use the repeat previous option to remove the time required for the annotation. So you can also use the smart polygon to create automatically detects the classes. So you have to annotate each and every images in your dataset for your project. So it takes more amount of time based on your annotation speed. After the annotation is completed, you can see what are all the images annotated in your dataset. So there are 55 images annotated for our dataset. So you have to select add dataset images. So in that you can see there are many percentage for your project. So you have to select more amount of percentage for the train and then less amount of percentage for the valid and the test. So after the percentage you have to select add images. So that's it. In today's class we have created annotation for our dataset fire detection using YOLO V9. In the upcoming class we are going to train our dataset using the YOLO V9 model. So let's see you in the next class. Welcome everyone. In today's class we are going to train our dataset using the YOLO V9 model in the RoboFlow website. So you have to select the new version. So in that you can see your source images, what are all the images you have annotated in your dataset and what are all the classes available for your dataset. So you can also see the valid, train, testing dataset images. In the pre-processing you have to select continue, augmentation also you have to select continue, at last you have to create your version. After that you have to export your dataset. For that you have to select that and then you have to select your model, that is YOLO V9 model, and then you have to select download zip to computer. At last you have to select continue for downloading your dataset. After the download is completed, you can see the test folder. In that you can see the images. So these are the images annotated, also the labels which contains the coordinates. So you can also see the images available in the train folder. So after that you have to close that. So after the completion of the data set, you have to train your model. In the RoboFlow website, you can train your data set with 3 credit points. So that is 3 free credit points for training your data set. For that only we are going to use that option. So you have to select train with RoboFlow. So you have to select first option and then you have to select start training. So that's it. You have to wait for the training process to complete in the RoboFlow website. So you can also see the estimate amount of time. After the training is completed, you have mail notification for training completed in the RoboFlow website. So you can also see the mean average precision training graph for your data set. With the epoch of 200, it goes around to 350 epochs. After the 350 epoch is completed, your model is well trained. So you can also see the remaining amount of time required for training your model. So in today's class, we have discussed about how to train our data set with the YOLO V9 model in the RoboFlow website. In the upcoming class, we are going to discuss about how to validate these data set with the trained YOLO V9 model. So let's see you in the next class. Welcome everyone. In today's class, we are going to discuss about how to validate our data set with the trained YOLO V9 model in the RoboFlow website. In the previous class, we have trained our data set with the YOLO V9 model. So we are going to validate each images with our YOLO V9 model. So in that you can see your mean average precision percentage, that is 99.5%. Your model is trained. So you can also see the training graphs. So in the output you can see the fire source around 61%. So that is well trained with the YOLO V9 model. So you can also select any one of the choices. So you can select shapes and predictions, labels. So we are going to select the fire label. So we are going to validate each images. For that you have to open any one of the dataset image. So you have to drag and drop any one of the image. So you can see the fire source around 85%. So that is our dataset is well trained with the YOLO V9 model. So you can also validate other images also. So we have to select any one of the images and then drag. So you can see again it shows around 85%. So we are going to drag other images. So we are going to choose any one of the images downloaded from the Kaggle website. So you have to drag and drop. So you can also select the threshold level. The file shows around 25%. So in the today's class, we have completed how to validate our trained YOLO V9 model in the RoboFlow website. In the upcoming class, we are going to discuss about how to run this project in the PyCharm IDE. So let's see you in the next class. Welcome everyone. In today's class, we are going to see about how to run our project in the PyCharm IDE. Before running our project, there are many types of options available in the RoboFlow website for running our project. So the first one is the image. So in the image, you can see the different kind of programming languages like Python, Curl, JavaScript, Swift and .NET. And also you can see the code for each programming languages. So you can also copy them and paste in the PyCharm IDE for running your project. Also, you have to see the information for running the project. So you can see what are all the packages you have to install for running this project. So you have to verify each and every line for running your project. And the second one is the video. So you can also use the video for running your project. So in the object detection, you can also see the code for running your project. And also you have to download the RoboFlow package for running your project. So you have to choose your MP4 file in that code. So after that, you can see the clip and gaze detection options. You can also choose that for running your project. So this is the second method for running the project in the video. The first one is the image and the second one is the video. And the third option is the cloud platform. In that you can see the two options available. The first one is the Docker and the second one is the native Python. So you can also see the packages installed for that native Python, that is inference GPU and inference. You have to install that package. For the Docker, you have to install the inference CLI and server start for running this project. So this code is for the cloud platforms like AWS, GCP and Azure. So you can also use this code for running this project in the cloud platforms. And the last option available in the RoboFlow website is Edge device. So you can also see what are all the programming languages available for the Edge device. So Edge device like NVIDIA and other Edge devices. So you can see the programming languages like Docker, native Python, NVIDIA Jetson, Raspberry Pi and other options. You can also see the information for running this project. So you have to install all the packages required for that code. So you can choose any one of them. So that's it. In the today's class, we discuss about what are all the platforms available in the RoboFlow website for running our project. In the upcoming class, we are going to run our project in the PyCharm IDE. So let's see you in the next class. Welcome everyone. In today's class, we are going to run our project in the PyCharm IDE. For that, you have to create your folder and open that folder. Inside the folder, you have to right click and open with PyCharm IDE. So you have to select that option. If you don't have this option, you have to open the PyCharm IDE and then you have to create your folder. After that, you have to create your Python file in the PyCharm IDE. For that, you have to select your folder and right click and then you have to select new Python file. So you have to type your Python file name. For that, our project name, fire detection. So you have to select enter. Before running your project, you have to install what are all the packages required for your project. For that, you have to select the settings option. So you have to open the settings. In that, you have to select the Python interpreter. For our project, I am going to use the Python 3.9 interpreter. You can also choose any one of the interpreter for running your project. After selecting your Python interpreter, you have to download the packages. For that, you have to select plus icon for installing the packages. So you have to type your package name in the PyCharm IDE. The first one is the RoboFlow. For that, you have to type RoboFlow. And then you can see the RoboFlow package is available. And then you have to select and download that package in the PyCharm IDE. So after that, we are going to install the other package, that is inference. So you have to type inference. So you can see the inference package is available. You have to select that and then you have to select install package. So you have to wait for the package to be installed. After the package is installed, you have to close that. And then you have to select OK. So that's it. So this is the way to install the packages in the Python IDE. So these are the two packages required for our project. So let's start our coding for our project. First we are going to import the packages. For that you have to type from RoboFlow, that is the RoboFlow package, import RoboFlow. So you have to import the RoboFlow package. After that you have to type rf, that is variable, and then you have to type RoboFlow package. Inside that you have to type the API key. For the API key you have to open the RoboFlow website. In the version you have to select the export dataset. In that you have to select show download code. And then you can see the API key for your project. So you have to copy that. So you have to copy the API key and paste that inside the quotation. So in the second line we have imported the API key for our project. After that you have to type project equal to, that is the variable, and rf dot workspace and dot project. Inside the project you have to type your project name. So that is first class we have created our project name. For that you have to copy that and paste inside the quotation. So in the third line we have imported our project workspace. After that you have to type model equal to project dot version of 1 dot model. So we have imported our YOLO v9 model from the RoboFlow website. So that is the trained YOLO v9 model in the RoboFlow website. After that you have to use the model again. We are going to predict the images. For that you have to type predict of. Inside that you have to type your JPG file name, that is any one of your dataset name, comma, and then you have to type confidence score for your project. So you can type any number of values. For that we are going to type 20 and dot save. We are going to save that file inside the JPG. So b.jpg is your own choice. You can type any one of the name. So that's it. This is the code for running the project in the Python IDE. In the first we are imported the RoboFlow website, and then we are imported the API key for our project, and then we are imported the project workspace. At last we are imported the model, that is the trained YOLO v9 model, and then we have used the trained YOLO v9 model to predict the images, that is a.jpg with the confidence score, and then we are saving that image in the again b.jpg file. So you have to run this project. So we can see our project is completed successfully. So we can see the process finished. So you have to open the b.jpg. Before that you have to open the a.jpg. So in that you can see nothing is predicted. In the b.jpg you can see our fire is detected using our YOLO v9 model. So that's the end of this course. Hope you learned something about YOLO v9 training process and also dataset annotation and also RoboFlow website. Hope I can see you in the upcoming courses taught by me.